Hello, this is Small Head Big Problems. I'm a small head and I've got big problems. So we are back for episode 2 of solving TMUA questions with no prep in less than 10 minutes. So let's go. Can you beat me to it? Yeah, last time the problems weren't too interesting. I'm continuing on. These are now going to be problems 4, 5, and 6 of the 2016 paper 1. Okay. Okay, question 4. The sequence AN is defined by the rule n equals -1 to the n minus -1 to the n minus 1 plus -1 to the n plus 2 for n greater or equal to 1. Find the value of the sum from n equals 1 to 39 of AN. Okay, let me copy this question to the board. Right, so in -1 to the n is going to be either plus or -1, right? If n is even, it's +1. If n is odd, it's -1. Let's have a little exploration, I suppose, starting with A1. So A1 will be -1 to the 1, which is -1, minus -1 to the n minus 1. So that'll be minus +1. And then n plus 2 will also be odd. It'll be 3. So that's -1 again, -3. So A2 will be, so this will be 1. This will be -1, and this will be let's see, sorry, 4 -1 to the 4, so it's a +1, which is 3. Okay. Let's think about this. So I mean, these ones will definitely always be different signs, so they'll kind of, well, since there's a minus, basically they'll add up. I mean, look, -1 to the n is just -1 to the n minus 1 plus 1, right? Because extra minus just, yeah, just kind of multiplies by -1 again. And then adding a 2 will, well, basically, like if n is, even, n plus 2 is also even. If n is odd, n plus 2 is also odd. So that means like it's the same value as -1 to the n, right? I mean, essentially, it's -1 to the n times -1 squared. -1 squared is 1, so that goes away. So basically, this is just 3 times -1 to the n, right? Which is kind of what I suspected, right? A to the -1, A1 is -3, A2 is 3, so that seems to work out. So this sum is just 3 times -1 to the n. Add it all up, 39 times, right? So basically, it'll be like -3 plus 3 minus 3 plus 3 minus 3, etc., etc. And then, finally, it will end on a -3, right? So obviously, all these pairs will cancel out, and then it ends on a -3, right? So yeah, I mean, basically, from 1 to 38, they'll be paired up, right? Since 38 is even, they'll be paired up into 19 pairs, and then we'll just have a -3 hanging out the back. So the answer is B. Moving on to question 5. I forgot to ask you to try it yourself. Hopefully you did. What is the total area enclosed between the curve y equals x squared minus 1, the x-axis, and the lines x equals -2 and x equals 2? All right, have a go at this yourself. I'll just copy it to the board. Okay, so I mean, this seems like a kind of just standard integration question, but do be careful to draw a sketch because we want the total area, right? And this function can get negative, right? So if you just integrate between -2 and 2, you will get the wrong answer, right? That's not how you want to do it. So seems really easy, but it's kind of not. So x squared minus 1, right? It will just be the x squared graph like this, but shifted downwards by 1. So it'll be like that. Okay. So what are these roots here? Right? So you just need to solve x squared minus 1 equals 0, which gives you x equals plus or minus 1, okay? So 1 minus 1. Cool. So total area between the lines, x equals minus 2, x equals 2, and the x-axis. So we want like this, plus this, plus this, right? So remember that like this area, if you integrate the function between minus 1 and 1, it will give you a negative answer. It will give you minus the area here that I colored in orange. So yeah, be careful about that. So what we want to do is, well, first of all, let's just integrate x squared minus 1, right? Just do the indefinite integral, sorry, which is going to be x cubed minus x plus c. And then we'll integrate between minus 2 and 1. So that's going to give us, just plug in, sorry, minus 1 in there. Take away, plug in minus 2. So I'll be minus 1 over 3 plus 1, and then minus 8 over 3 plus 2. Actually, I do kind of like to pair up these terms normally, simplify those together. So it'll be minus 1 plus 8. So it'll be plus 7 over 3 here, and then 1 minus 2, so minus 1. So it'll be 4 over 3. Clearly, this area is also the same, right? Because of the symmetry. So we'll have basically twice that. Probably would have been easier to use the positive limits, but anyway. And then you know what? I mean, I'll also kind of use the symmetry here using the positive limits. I'll integrate between 0 and 1, right? And then just multiply the whole thing by 2. So 1 and 0, because like when you plug in 0, you get 0. So that's really easy. So it'll give us 1 over 3 minus 1. So that's minus 2 over 3. Negative answer as we expected. So overall, let me just add up these two, obviously turning the negative to a positive. So 4 over 3 plus 2 over 3. And then I'll just multiply that by 2. That'll be our answer. So that's 6 over 3, which is just 2. So times 2 is 4. That's answer C. Let's check. The power of a sketch. Really don't underestimate it, okay? Like just please sketch things. All right? Just, for your enjoyment, for your understanding. Okay, question 6. P, Q, and R are each mixtures of red and white paint. Ooh, I like that. The percentage by volume of red paint in P is 30%. The percentage by volume of red paint in Q is 20%. The mixtures P, Q, and R are combined in the proportion 12 to 5 to 3 respectively. If the resulting mixture contains 25% by volume of red paint, what percentage by volume of mixture R is red paint? Okay, so I think a good strategy here is not to work with either percentages or ratios necessarily, but like find a quantity of sort of P, Q, and R such that like, the calculations are easy, right? So mm, 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 mm. Mm. Okay. Uh, right. I mean, 12 and 5. Okay. Okay. Well, I mean, say 12 units of P and 5 units of Q and 3 units of R are combined, right? So if it's 12 units of P, so kind of overall there is 12 plus 5 plus 3 equal parts, right? Um, so 17, so 20 parts. Okay, 20 equal parts. Yeah, in total, so that's a total amount of paint. Cool. So if we just can calculate the amount of red paint in there, Well, sorry. Well, we're giving the amount of red paint. So we're saying the red paint is 4 parts, right? 4 parts red. Okay. Then 12 parts, okay, so yeah, so 12 parts is P. So 30% of 12 is what? 12 times 10 over 3, I'm sorry, times 3 over 10 is 3.6. Ah, yeah. So that's not great, to be honest, but okay, we'll work with that. Um, 20% of Q, so 20% of 5, that's 1. So that's good. Uh, oh. Hmm. Well, that's not good at all, right? Because there's 20 parts, 4 parts. Oh, I'm sorry, 5 parts need to be read. Sorry, 25% of 20 is 5, right? A quarter of 20. Right. So from P we get 3.6 parts of red. From Q we get 1 part of red. So together 4.6 parts of red, right? P plus Q, 4.6 parts of red. And so we need 5 parts of red. Okay, so we need zero point 0.4 parts of red um red to achieve this, and that would be as part of 3 equal parts. Okay, red, R is 3 equal parts. So let's just try and it's a percentage, so let's try and put this fraction over 100. I mean, it's gonna be C, really. I can see that because it's the only one with a third, and we can't really put this over 100. But we can just multiply it. We just multiply the top and bottom by 100, right? To kind of turn this sort of like fractional or decimal, thing to scale it to a percentage, right? So if we do that, just times by 100 times by 100, then we'd get 40 over 300, divide the zeros. Uh, yeah, wait, I'm sorry. What? Yeah. Hmm. Sorry, I'm sorry. Just scale it by 100. My bad. Just scale it by 100. Don't. Yeah. So sorry. So 40. So sorry. 40 over 3, which is 30. 40 is like 3 times 13 plus 1. So 13 and a third percent is the answer. It's C, as I thought. And is that correct? Yep, that's correct. Okay. Um, did you figure those out? Let us know if you found a different solution in the comments. Better solution, hopefully. If you enjoyed me, please make sure to like and subscribe. And if you are interested in getting private tutoring, send me a message. My details are in the description. See you next time.